So on the previous video, we had some function gx, and then it's times by its derivative, which is g prime x dx. So we know that when we have a function like this one, then we can take u as being gx, and then we know that its derivative will be just du equates to g prime of x dx. So knowing this fact, just ignore, knowing this fact, then we can resubstitute again. We have u du, and then we can simply use the exponential rule to just integrate that one. So it will be u to the power of 2 divided by 2 plus c. Then that's your final answer. So now let's say you have something. So knowing this fact, you can just use it to actually work out here. So firstly, you have to know how to recognize on each of these problems what you take as your u. So all of these problems are actually u substitution. So on this first one, you have u. So note that on the exponent of e, there is x to the power of 2. If you derive x to the power of 2, it gives you x times 2. Then the 2 you take out. So you have x to the power of 2, and then du equates to 2x dx. And then to make this one the subject, you can just say it's 1 over 2 du equates to x dx. And now you have an integral of u, which is e to the power of u. Du, it's just in half. Just put it in front here, du. And then now you can see this one and that one is the same as this one. So having this one, you know that the integral of e to the power of x, or to the u, is just e to the power of u, and then it's plus c. Still have a constant here. That plus, the half goes in front, and then you just substitute your u back. You have half e to the power of x squared plus c. Okay, and then you move on. Let's move on to this one. This one, where do you take? So know that which one you take is a u substitution. You take the whole sign, or you take the 2x. Now on this one, you know that there's a 2 multiplied here. If you derive this x, it gives you 1. So you can simply say, okay, it's 2x, and then it's du. Sorry, you couldn't see there. Du equates to 2 dx, and then you just make du the subject, dx, and then you have that one. So you can simply substitute again. You have sine of u times half of du, which is just goes into the front. Then you have du there. So you know the integral of sine of u is just negative cos of u, and then it's just plus that one, and you still have a half here. It's plus c, and then the final answer will just give you, let me just write it here. The final answer will be negative half cos of, substitute your u back, which is 2x plus c. Then you're done with that one. Let's move on to this one right there. So this one, you just take u as your sine. That one, you know that, don't take to the full, just take the sine, because you know the derivative of sine is just positive cos, so it works perfectly. So it's sine of x, and then du equates to cos of x, and then dx. And then now you know that the cos of x is actually the same as that one, so you can just took it back here and say u to the power of 4 times du. Still have an integral there. So this one is just the rule, the exponential rule, and then you just write there, divide by 5 plus c, and then you substitute your u back. You have you have sine of x to the power of 5 divided by 5 plus c. Okay, let's do our last one. So our last one is this one. So this one, you also take the inside function of that one. You know that the derivative of e to the power of x is just e to the power of x. So you say u equates to e to the power of x. Du equates to e to the power of x. This is a less struggle. This is actually the simplest one you can find. And then you just have e to the power of x times dx, and then you just have sine of u equates to du, and then this one will give you the integral of this one, will just give you negative cos of u plus c, and the negative cos of u, just substitute your u back, you have ex plus c, then you're done.